This lesson deals with inverse Laplace transforms using MATLAB. You can find these notes in the ECE202 ebook in Chapter 9, starting on page 26. Suppose we have the following function f of s, which is equal to 1.28 times 10 to the 7th times s plus 400 divided by s squared plus 400 squared quantity squared times s plus 1,000. We start to run the MATLAB program. Here I'm running the educational version of it. The first thing we need to do is declare the variables. These are our symbols s and t, and they can be in any order. Our function type now f is equal to 1.28 e to the 7th times the quantity s plus 400 divided by the overall quantity, inside of which is s squared plus 400 squared, and that quantity squared times s plus 1,000, and then ending that denominator quantity. When you hit enter, it echoes back what you typed, and you can check for any typing mistakes. The command for the inverse Laplace transform is iLaplace. First term is the function that you're taking the inverse Laplace transform, in this case the capital letter f. It's a function of s, and I want my results in terms of t. I'll just call that little f of t. Be our definition here of our inverse Laplace transform. The order here is very important. When you hit return, it gives you the answer. This is a little bit hard to read, and so you could use the pretty command and say pretty and then the function f. And f is the following expression: minus 24 over 4205 e to the minus 1000t, 24 over 4205 times the cosine of 400t, plus 143 over 4205 times the sine of 400t, minus 560 over 29t cosine of 400t, plus 240 over 29t sine of 400t. Let's do an example where we know the answer. So let's redo the example on page 23, but this time using MATLAB. If you recall, one of our answers was having the impulse function. In MATLAB, this is referred to as the Dirac of t. Again, we start the program and we'll declare our variables. In this case, I'll put t first and then s. Again, the order doesn't make any difference. Then our function f was s squared plus 4s plus 5 divided by s squared plus 3s plus 2. Hit enter and it echoes back what you typed. You can check again for a typing mistake. Using the inverse Laplace command, our function f, which is a function of s, and our result will be f as a function of t. Hitting enter, we get the results, Dirac of t minus e to the minus 2 times t plus 2 times e to the minus t. Clean this up a little bit by using the pretty command again, and just get Dirac of t minus e to the minus 2t plus 2e to the minus t. Just taking that asterisk out of the expression. Let's do another example. Let's take the example on page 25 and let's redo it with MATLAB. Again, declare our variables, s and t, and our function was 4 times the quantity s plus 3 divided by the quantity s times s plus 2 squared. Hit return, it echoes back the expression, and we're going to ask for the inverse Laplace transform of f as a function of s, and our result will be f of t. Then we get 3 minus 2 times t, e to the minus 2t, minus 3 e to the minus 2t. Again, using the pretty command, cleans up a little bit here. I got 3 minus 2t times e to the minus 2t minus 3e to the minus 2t. And this agrees with the results we had on page 25. These are some examples of using MATLAB to find inverse Laplace transforms.